In this video, you'll see how to use elimination to solve systems of equations. So before we use elimination, have you ever noticed you could take two equations, 15 plus 6 equals 21, 3 plus 8 equals 11, and you could add these together. So 15 plus 3, that's 18. 6 plus 8, that's 14. 21 plus 11, that's 32. This is still a true statement. 18 plus 14 equals 32. You could even subtract these two equations. 15 minus 3, that's 12. Positive 6 minus positive 8, that's negative 2. 21 minus 11, that's 10. Still a true statement. We use this idea when we solve systems of equations by elimination. So when I look at this equation, one of the things that jumps out to me is this positive 5y in the top equation and negative 5y in the bottom equation. Now listen, you could of course still solve one of them for x or for y and then use substitution. But when I see a case like this, this is ripe for solving by elimination. So what I want to do is I want to add these two together. 2x plus 6x, that's 8x. The reason I chose to add them together, a positive 5y plus a negative 5y, that eliminates the y because that's a zero pair. And 17 plus negative 9, that's equal to 8. I can solve this equation for x. I find out that x is equal to 1. This is a system of equations. I want to find the point where those two lines intersect. So far I have the x-coordinate. Now I want to find the y-coordinate. So I choose either equation, substitute 1 for x, and now I'm going to solve this equation for y. So 2 plus 5y equals 17. Subtract 2 on both sides. 5y is equal to 15. Divide both sides by 5. Y is equal to 3. So the solution to both of those equations is 1, 3. If you substitute 1 for x and 3 for y in both of those equations, you'll get a true statement. Now let's take a look at this equation. Again, the thing that jumps out to me is I've got a 2y in both of them. But if I add them together, I'll get positive 4y. I want to subtract these two equations. So 7x minus 8x, that's negative x. 2y minus 2y is 0. And 24 minus 30, that's negative 6. Divide both sides by the coefficient. I know x is equal to 6. To figure out what y is, substitute what I know x is into either equation and solve it for y. So 48 plus 2y is equal to 30. I'm going to subtract 48 on both sides. 2y is equal to negative 18. Divide by 2. Y is negative 9. So 6, negative 9, that is the solution to this system. Alright, this one's a little more challenging. What do we notice here? Well, I can't just add or subtract these equations together to eliminate a variable. But what if I multiply this bottom equation by negative 6? Well, if I do that, I get negative 6 times negative x, that's 6x. Negative 6 times negative 8y, that's positive 48y. And negative 6 times negative 10 is equal to 60. What did multiplying by negative 6 do? Well, what it did is when I rewrite my system, now I can see that I can eliminate a variable. And it is okay to multiply the equation by negative 6 because as long as I do the same thing to all of those terms in the equation, right, it's still the same equation, still equivalent. So I'm going to add these two together. Negative 6x plus 6x is 0. Negative 4y plus 48y, that's 44y, is equal to 88. Divide both sides by 44. And we know y is 2. Well, next I want to figure out what x is. So I'm going to substitute what I know y to be. So negative x minus 8 times 2 equals negative 10. Negative x minus 16 equals negative 10. Add 16 to both sides. I get negative x equals 6. Divide by negative 1. X is equal to negative 6. So negative 6, 2 is a solution to this system. And finally, let's take a look at this last system of equations. What would you do to eliminate one of the variables? I think the most straightforward thing to do would be to multiply this bottom equation by 3. So I get negative 2x plus 15y equals negative 32. And then I have 21x minus 15y equals 51. And notice I can eliminate my y's here if I add these two equations together. So negative 2x plus 21x, that's 19x. My y's zero out. 51 plus a negative 32, that's also 19. I know that x is equal to 1. So now, let me substitute 1 for x, and I can solve either of these equations for y. Negative 2 plus 15y equals negative 32. Gotta add 2 to both sides. 15y equals negative 30. Divides both sides by 15. And we know y is equal to negative 2. So 1, negative 2 is the solution to this system. And that's how we use elimination to solve systems of equations.